Good morning, everybody. So today we're going to continue with our discussion of fractions. And today we're going to work on estimating fraction sums and differences. And our question is, how can you make reasonable estimates of fraction sums and differences? So let's look at the unlock the problem. Kimberly will be riding her bike to school this year. The distance from her house to the end of the street is 1/6 mile. The distance from the end of the street to the school is about 3/8 mile. About how far is Kimberly's house from the school? All right, so we can use benchmarks, 0, 1/2, 1 whole, to find reasonable estimates by rounding fractions to those three spots, to 0, to 1/2, or 1. And one way you can do that is by using a number line. So if we look at 1/6 and 3/8, we would place 1/6 on the number line. Okay, and we see that 1/6 would be right there. Remember that 1/6 means that there are 6 parts or 6 pieces in one whole. All right, and the numerator tells us that there's only one out of those 6 pieces. So half would be 3/6, right? Well, what is 1/6 closer to? Is it closer to 0, 0/6, which is 0, or is it closer to 1/2? Well, just on number line, I have to go 2 jumps to get to 1/2. And to get back to 0, I don't have to go 1. So 1/6 is closer to 0. So the fraction is between 0 and 1/2. The fraction 1/6 is closer to the benchmark, 0. So we're going to round 1/6 to 0. Now we would try to find 3/8. So 3/8 means that there's 8 pieces or 8 equal sections in the whole. And 3/8 would be right there. And it's 1 away from 4/8. And 4/8 is 1/2. To go back to 0, I'd have to go back 1, 2, 3. So it's easier to jump to 1/2, or quicker to jump to 1/2 than it is to go back to 0. So in this case, the fraction still is between 0 and 1/2, but the 3/8 is this time closer to 1/2. So round 3/8 to 1/2. Now we're just going to add the rounded fractions. 1/6, we round it to 0. 3/8, we round it to 1/2. So 1/2 plus nothing is 1/2. So her house is about 1/2 mile from school. Simple as that today. Okay, so let's look at 262. All right, another way we can do that is just using mental math. Okay, we can compare the numerator and the denominator to round a fraction and find a reasonable estimate. So let's look at this subtraction problem. We have 9/10, and we're going to take away 5/8. So 9/10, the numerator is about the same as the denominator, right? Another way of thinking that is, what's half of 10? Half of 10 would be 5, right? So halfway would be 5/10. Well, 9/10 is clearly greater than 5/10, right? So we would round that to 1 whole. 5/8, think the numerator is about half of the denominator, right? What's half of 8? Half of 8 is 4/8. So 4/8, the 5/8 is close to 4/8. So we're going to round 5/8 to 1/2. Now we're just going to add our rounded fractions. 9/10 we said is closer to 1. 5/8 we said is close to half. Well, what's 1 take away half? Well, there's 2 halves in a whole, right? So 1/2. All right, so let's try these. We have 2 7/8. And let's focus on the 7/8. Well, half of 8 would be 4/8, right? Half of 8 is 4/8. 7/8 is actually closer to 8/8 than it is to 4/8. So this is actually about one whole. 2 7/8 is about one whole. So let's add that, and we'd have 3. So 2 7/8 is actually closer to 3. And 2/5. 2/5. What's half of 5? Well, 2 plus 2 is 4. 3 plus 3 is 6. Well, half of 5 is 2.5. So 2.5 out of 5 parts would be halfway, right? 2.5 plus 2.5 is 5. Well, 2/5 is actually pretty close to 2.5, right? It's closer to 2.5 than it is to go back to 0. To go from 2 back to 0, I jump twice. To go from 2 to 2.5, I only have to go a half a space. So I'm going to round 2/5 to 1/2. So what is 3 take away a half? 2.5. All right, 1 8/9. So that 8 is really close to the 9, right? It's almost one whole. So we're going to round 1 8/9 to 2. So we say 8/9 is close to 1. 1 plus 1 is 2. 4 8/10. Well, 8/10, that's also almost the same as the denominator. So I'm also going to make that 8/10 close to 1. And 4 plus 1 is 5. So now we just add those. 2 plus 5 is 7. All right, let's look at page 263. Estimate the sum or difference. Round 5/6 to its closest benchmark. Well, again, if we needed to do this on a number line, we'd have 0 there. We'd have half right there in the middle, and we'd have one whole right there, right? And 5/6 would mean that we have 3. I'm going to put the fraction at the top. 1/6, 2/6, 3/6, which is the same as 1/2. 4/6, 5/6, 6/6. All right. So then let's look at 5/6. 5/6 is right there, right? Well, 5/6, that's clearly closer to 1, right? Than it is to 1/2. We'd have to go back 2 to get to 1/2, and we only have to go forward 1 to get to 6/6. So 5/6 is closest to 1. 3/8. So again, if we were doing a number line, this time we'd have eighths. All right, and we'd find 3/8 on the number line. And 3/8, is that closer to 0 or is it closer to 1/2? It's closer to 1/2. So it's around 3/8 to 1/2. Now we all have to do is add to find our estimate. 1 plus a half is 1.5. All right. Now, number 2, 5/9. What's half of 9? Half of 9 is 4.5. So 5, that's pretty close to that, right? So I'm going to say 5/9 is close to 1/2. Half of 8 is 4/8. 3/8 is close to that. So I'm also going to make that 1/2. Oh, well, 1/2 take away 1/2 is 0. Okay, so 5/9 take away 3/8 is about 0. 6/7. Well, half of 7 is 3.5. Well, 3.5, when we compare 6 to 3.5, the 6 is actually only one jump away from 7, and it's 2.5 away from 3.5. So it's closer to 1. So I'm going to round 6/7 to the benchmark 1. 2 and 4/5. We're going to focus on the 4/5. And half of 5 is 2.5. When I look at the 4, it's only one jump away from 5. And it's over 1 to get back to 2.5. So I'm going to make the 4/5 1, and 2 plus 1 is 3, right? Because we have 2 and 4/5. So the 4/5 is closer to another whole. So 2 plus the whole gives us 3. And 1 plus 3 is 4. So my estimate is about 4. All right, 5/6 plus 2/5. What's half of 6? Half of 6 is 3/6. So we'd go 4/6, 5/6, 6/6. Okay, so go from 5/6 to 6/6, that's only 1. To go back to 3/6 would be 2. Two spaces, right? So 5/6 is closer to 1. And 2/5, we've actually had this one already today. And we said that 2.5 is really close to 2. So 2 is closer to 2.5 than it is to 0/5. So we'd say 2/5 is close to 1/2. And 1 plus 1/2 is 1.5. All right, number 5. 5/8. Well, half of 8 is 4/8. One whole would be 8/8. So 5/8 is closer to 4/8 than it is to 8/8. So 5/8, I'm going to round to 1/2. Half of 5, we know is 2.5. 1 is closer to 0/5 than it is to 2.5/5. So I'm going to change or round 1/5 to 0. 1/2 take away is nothing is 1/2. All right, 1/6. Half of 6 is 3/6. Isn't 1/6 closer to 0/6 than it is to 3/6? Yeah, so let's round 1/6 to 0. And 3/8, half of 8 is 4/8, and 3/8 is only 1 away from 4/8. And it's 3 away from 0/8. So I'm going to make 3/8 1/2. And 0 plus 1/2 is 1/2. 6/7 minus 1/5. Half of 7 is 3.5. So to go from 6/7 to a whole number would be just one jump, because we only have to go 1/7 to get 7/7. But to go back to 3.5, we'd have to go back 6, 5, 4, and then a half. So 2.5 jumps backwards to get from 6 to 3.5. So this is closer to one whole. And then half of 5 again is 2.5. And the 1 is going to be closer to 0/5 than it is to 2.5. And 1 take away nothing is 1. All right, let's look at number 11. Number 8. 11/12. The numerator is almost the denominator. So that's got to be 1. 6/10. Half of 10 is 5/10. And 6/10 is really close to that. So 1/2. Add them together, we have 1.5. 9/10. Well, the numerator is almost exactly the same as the denominator. So that's going to be 1. Take away a half. Well, that's a half. 3/6. Well, half of 6 is 3. So I'm going to keep that as 1/2. 4/5. We know that 2.5 is half of 5. And 4 is actually almost the same as the denominator 5. So that one's going to be close to 1. So 1.5. Number 11. Lisa and Valerie are picnicking in Trough Creek State Park in Pennsylvania. Trough Creek State Park in Pennsylvania. Lisa has brought a salad that she made with 3/4 cup of strawberries, 7/8 cup of peaches, 1/6 cup of blueberries. They ate 11 cups of salad. About how many cups of fruit salad are left? Well, let's see how much they have to start with. So we have 3/4 plus 7/8 plus 1/6. All right, well, 3 is almost the same as the denominator 4, so that's about 1. 7, that's about the same as the denominator 8, so that's also close to 1. And 1/6, that's real close to 0. Okay, so we had about 2 cups to start. They ate 11 twelfths. So basically we have 2 cups, take away 11 twelfths. 11 twelfths, that numerator is almost the same as the denominator, so that's 1. So basically we have 2 take away 1. Okay, so about 1. We have about 1 cup left. Now let's go ahead and put the word about in front of that. Well, about 1 cup left. All right, number 12. At Trace Park in Mississippi, there's a 40-mile mountain bike trail. Tommy rode half of the trail on Saturday and a fifth of the trail on Sunday. He estimates that he rode more than 22 miles over the 2 days. Is his estimate reasonable? 22 miles over 2 days. Well, let's see. Half of 40. What's half of 40? Wasn't that 20? 20 plus 20 is 40, so half of 40 would be 20 miles. Well, if he rode 20 miles on Saturday, he's already got almost 22 miles. I think that's reasonable. "13. Explain how you know that 5/8 plus 6/10 is greater than 1. Well, okay. Half of 8 is 4/8. Half of 10 is 5/10. Okay, well, 5/8 is greater than 4/8. So 5/8 is greater than a half. And 6/10 is greater than 5/10. So that's greater than a half. So both fractions are greater than 1/2. 1/2 plus 1/2 equals 1 whole. So if both fractions are greater than 1/2, I guess the cat wants to do math with us today. So if both fractions are greater than 1/2, it's got to be greater than 1 whole. All right, so number 14. Nick estimated 5/8 plus 4/7 is about 2. Explain how you know this estimate is not reasonable. Well, half of 8 is 4/8, and half of 7 is 3.5. So 5/8, that is greater than a half, a little greater than a half. And 4 is slightly bigger than 1/2. But 1/2 plus 1/2 is equal to 1, not 2. So both of these fractions are less than 1 whole, right? So that's not reasonable. Both fractions are less than 1 whole. So they would not add up to 2. All right, and 15. Aisha painted 5/6 hour in the morning, 2 1/5 hours in the afternoon. Estimate how long Aisha painted. All right, Aisha painted for about how long in the morning? Oh, it says 5/6 hours in the morning. Well, the numerator is almost the same as the denominator, so we know that when the numerator and the denominator are exactly the same, that equals 1. So that's going to be about 1 hour. In the afternoon, she painted 2 1/5 hours. Well, let's look at the 1/5. That's close to 0/5, right? Half would be 2.5. So it's actually closer to 0. So I'm going to say she did about 2 hours in the morning, in the afternoon. All right, so how long did she paint overall? Well, 1 hour in the morning, 2 hours in the afternoon. So she painted about 3 hours in the morning and afternoon combined. Okay. So that's our work on estimating. And the reason that's going to be helpful for us is to see if our actual sums and differences are reasonable when we are adding or subtracting fractions with opposite or unlike denominators. So in our next lesson, we'll be working on factors that are multiples to form a product using fractions. So until then, I will see you soon.